Hello everyone, this is Mr. Kozlowski. Welcome to Unit 2 Motion. We are on learning targets 3 and 4 now. These are our last two learning targets of the unit, and the thing that's going to be different about this video, it's combined. I am combining learning targets 3 and 4. You will have two separate quizzes on this in terms of formative quizzes, but one quiz for this whole lecture. So one lecture, one quiz, two learning targets. So before I talk about learning targets 3 and 4, I want to quickly review what we have done thus far up until this point. We have talked about learning targets 1 and 2, which dealt with motion maps and position versus time graphs. And that answers one of the questions of how do we model motion. We use motion maps, position versus time graphs to show the motion of an object. You have to be able to do both of those for the test. Number 2. What variables do we need to model in motion? We need to model its object's velocity, position, and time. We have defined those in class. If you are still having troubles with some of those definitions, please let me know. The one definition that a lot of students get confused about is speed versus velocity. You don't really have to know these two terms distinctly yet because I use them interchangeably in class. However, when you get to physics, you have to know the difference. What's the difference? Speed is the rate of distance divided by time, so how far an object travels in a given amount of time. Velocity is speed with direction. So if you remember from position versus time graphs, I had you doing some velocity versus time graphs as well. Well, there was a positive and negative speed. That positive and negative indicated the direction the object was traveling. So velocity, speed with direction, speed, rate of distance divided by time. So learning target 3, what are we going to talk about? What are we going to add? Well, in this case, we're going to talk about acceleration. And students need to be able to identify acceleration in a given description. Here we have a picture of Usain Bolt, a world-class sprinter, Olympic medalist. I believe he won the gold. He's pretty fast. So if we look, when he starts a race, if you think about a sprinter, he's down in the block. You can see the blocks, and he puts his feet there, and he's in a very coiled and loaded position to explode out of the blocks and start sprinting. Well, at that moment when the race starts, he is accelerating very, very quickly to get to his top speed. Acceleration is what we're trying to define here. And if we look at the example of a sprinter running, there's many different points of acceleration throughout that whole race. At start, maybe there's a turn. At the end of the race, maybe, when he's slowing down and he's finished. We have to be able to define those moments of acceleration in a given model or situation that's provided to you. That's the point of this learning target. So how do we identify acceleration? We have to understand what's its definition first. Acceleration is the rate of change of motion in an object. This includes speed and direction. So to put it in simple terms, an object is going to accelerate when it's changing speed, when it's changing direction, or both at the same time. So if it's speeding up, slowing down, it's changing, or speeding up, slowing down, it is accelerating. If it's turning or moving in a different direction, it is accelerating. If it's doing both at the same time, it's accelerating. So acceleration occurs a lot more than people think about it. People generally think of an object moving, all right, it's got speed. But is it accelerating? Yeah, quite often it is. And we're going to identify that in this learning target. So again, acceleration is the rate of change of motion. So here we have a picture of 4 different scenarios of a car, and we have an arrow indicating the object's velocity and then also the object's acceleration. So my question is, which cars are speeding up, which cars are slowing down? And because speeding up and slowing down are forms of acceleration. So if we look here at the first car, letter A, velocity and acceleration are going in the same direction. Obviously, the arrow length indicates that they're not the same value, but we're not concerned about the quantitative value right now. we are concerned about whether or not it's speeding up or slowing down. If velocity and acceleration are going in the same direction and the speed is increasing, you have acceleration. So this object, letter A, would be speeding up. Object B, they are then going in different directions. Acceleration is working against velocity in this case, and we'd have a negative acceleration in this case versus a positive velocity. Well, that object then is slowing down. Letter C is similar to letter B, only in the fact that the directions have now changed. If negative velocity is to the left, the object is going to the left. However, it has a positive acceleration in this case. If it's going to the right, they cancel each other out. That object is slowing down. So again, similar to object B here. And then object D, you have the same as object A, except it's just going in a different direction. So it's speeding up. It's accelerating as well. So again, acceleration, if you think about it in terms of speed, if it's speeding up, slowing down, it's acceleration. Well, what about this scenario here? Let's say you were on a merry-go-round and your friend was pushing you at a constant speed, meaning you were going around the merry-go-round in a constant velocity. Is it accelerating? Why or why not? Well, the answer is yes, it is still, you are still accelerating if you are on a merry-go-round, even though that your speed is constant. The reason for this is that you are changing direction. So again, that goes just back to the definition of acceleration. It's the rate of change of motion. You can change motion by speeding up, slowing down, or by changing its direction. So with acceleration and velocity, direction is very, very important here. So just to kind of review, acceleration is the rate of change of motion. This includes the change in direction, speed, or both. Something I failed to mention before was the term deceleration. That term does not exist. A lot of students have this misconception of using deceleration as meaning for an object to slow down. An object accelerates when it slows down. So speeding up and slowing down are both forms of acceleration. We just call it acceleration. Deceleration does not exist. And finally, changes in direction are always examples of acceleration. So whenever you move, whenever an object turns, if you're in a car and it turns the corner, you are accelerating based off of our definition. Finally, learning target 4. Students will understand and demonstrate acceleration on a motion map. Students can show their understanding by drawing out a motion map and explain the variables of starting position, direction, changing speed, and time in terms of acceleration. So, now what you have to do, since we know the definition of acceleration, is that you must display this on a motion map or be able to identify it on a motion map. So, I'm not going to review the directions on how to make a motion map. You're just going to have to make slight changes to the dots, the arrows, and the time, the position based off of acceleration now. So what I want you to do is I want you, instead of me teaching this, I want you to think of the factors that we need to know about. Position, direction, changing of speed, and time. How do you represent those in a motion map, and how would they change based off an object that is accelerating, either changing speed, changing direction, or both? In your notes, what I want you to do is I want you to complete these tasks, and we will review these in class together, and I'll be looking for these when I come around and do your note check. Task 1, I want you to draw a motion map of an object that is accelerating for 3 seconds. So that should be pretty simple motion map there. Think about what do you have to change to show that the object's accelerating in this case. Task number 2, I want you to draw a motion map that shows an object traveling at a constant speed away from the origin for 2 seconds, stops for 3 seconds, and then accelerates for 4 more seconds. Again, think about what you need to do in the motion map to make sure it's accelerating or moving at a constant speed. Finally, task 3, this is a little different. I want you to describe this motion in terms of speed, direction, and time. Is it accelerating? Why or why not? So again, CER format comes into play here. Use what you have, use your evidence to explain, is this object accelerating or why not? So finally, to review, acceleration, again, it's the rate of change in motion. Is it change of speed, direction, or both? Is it speeding up, slowing down? Is it changing direction? Or is it any combination of those? If it is, it's accelerating. Number 2, you must identify when acceleration occurs in the problem. So you will be given a motion map and you will be asked to identify moments of acceleration in that motion. And then finally, number 3, you must draw an object accelerating on a motion map properly. So motion map displays and writing and drawing comes into play here. You need to do that properly. Now you're changing that the object is now accelerating. It's not moving at a constant speed all the time. So that being said, a couple things. 1, make sure that you do those tasks because that's what I'll be looking for with your notes. And 2nd, make sure you do the corresponding quiz for this because, again, there's still some confusion with students understanding that, yes, you must do the notes, you must do the quiz to get full credit for your homework completion. If you have any questions, please come to class with them, and then I'll see you in next class. Thanks a lot.